Hello, hello. Is anyone is in live? Hello. Good evening. Good evening. Good afternoon. Good evening. Whatever may be. Good afternoon or good evening. Good afternoon, everyone. Good afternoon. Good evening. Once you say me whether the video and the audio is clear. Once if you say me whether the video and audio is clear. Good afternoon. Good afternoon, everyone. Once if you say me whether the video and audio is clear. Any disturbance you are getting. Clear. Right. Done. Now, okay. Now, my dear friends, today we are going to deal with the chapter redox reaction. Now, but in this redox reaction, whatever may be we are going to study, these basics will play very crucial role in our entire chemistry, right? Now, but before going to the redox reaction, we have to get acquainted, or we have to be very clear with the some basics from the classification of periodic table. If some basics, if it is clear for you, now whatever may be the concept that we are going to study in our redox reaction, it will be very easy for you. In the redox reaction, the concepts are very less because it is a very small chapter, but these applications will play a very crucial role. Done. Now let me start our lecture. But before going to start our lecture, first of all, I want to recap some basics from the classification of periodic table, so that you may not get any difficulty while you are studying the redox reaction. ವೆಂಕಟೇಶ್, ಈಗ ಕನ್ನಡದಲ್ಲಿ ಮಾಡೋಕೆ ನನ್ಗೇನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಬಟ್ ಈಗ ಸುಮಾರು ಜನಗೆ ಅರ್ಥ ಆಗಲ್ಲಲ್ವಾ, ಸೊ ಅದಕ್ಕೆ ನಾನು ಇಂಗ್ಲಿಷಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಎಲ್ರಿಗೂ ಯೂಸ್ ಮಾಡ್ಬೇಕಲ್ವಾ. It should be used for everyone, right? The students who are seeing from the entire our India. But okay, right? Now, before going to start our redox reaction, first I want to make you clear your basics from the classification of periodic table. If these basics clear, instead of remembering which atoms atomic number, which elements atomic number this is and everything, so now for this one, that's the reason first we are going to see atomic size or atomic radius. Now, what will happen for the atomic size or atomic radius in the left to right in the periodic table? In the left to right in the periodic table, what happened to the atomic radius? What happened to the atomic radius? What happened to the atomic radius in the left to right? Left to right in the periodic table, what happened to the atomic radius? Ah. Left to right in the periodic table, what happened to the atomic size? My dear friends, once again you can think and you can say me. Don't be in hurry to say me the answer. This type of the basics, if it is clear, now the concepts are redox reaction, whatever we are going to study, it will be clear for you. Left to right in the periodic table, what happened to the left to right in the periodic table, the atomic size will be decreases. Left to right in the periodic table, atomic size will be decreases. Atomic size will be decreases because here the same electron will be added to the same shell, right? Now if you see lithium, beryllium, boron, carbon, nitrogen, oxygen and the fluorine, and this is a neon. Now here left to right in the periodic table, atomic size decreases. Why? Because here this is atomic number is 3, 4, 5, 6, 7, 8, 9 and this is 10. Now the first shell we are having, this is 1s2 and the 2s1, right? 1s1 is the first shell. For everyone or the every element we are having 1s2, 2s2. Next 1s2, 2s2, 2p1. Now see, the last electron is adding in the same shell. The last electron is adding in the same shell because the second shell we are having the 2s and the 2p. As the last electron is adding in the same shell, what happened to its nuclear charge? Nuclear charge will be increases. Due to the nuclear charge increases, valency electron will be attracted towards the nucleus strongly. That's the reason left to right atomic size decreases. Right? Clear? Now, as the left to right atomic size decreases means, now top to bottom what it will happen? Now top to bottom atomic size, what happened to the top to bottom atomic size? What happened to the top to bottom atomic size? What happened to the atomic size from the top to bottom? Now the left to right, if the atomic size, if it is decreasing means top to bottom it will be increase because the last electron will be added into the new shell. Right, good. Next, this is the first basic. Now the second basic, ionization energy. Now ionization energy left to right, ionization energy left to right increases generally, and top to bottom ionization energy decreases. Right? Ionization energy decreases. Next. And the third very most important concept that we are going to study, that is the electronegativity. If you remember this electronegativity values, now easily, very fastly, by seeing the compound itself you can say the central atom oxidation number, that it will play very crucial role in the identifying of the which one acids, base and the amphoteric oxide or any of the compounds nature. Here now how to identify the electronegativity? What is the role of the electronegativity? If any compound it has formed the bond, or if any, then this B is more electronegative than the A. If the B is more electronegative than the A, what the B will do, it will pull the bond pair of electron towards itself. When it is pulling the bond pair of electron towards itself for the B will get the partial negative charge, A will get the partial positive charge. Why the B is getting the partial negative? Because B is dragging the electron towards itself. Due to that It is gaining the electron. Gaining of electron is negative and the loss of electron is positive. My dear friends, you have to be very careful with this in the chemistry in the sign convention. Gain of electrons is negative, right? And loss of electron is positive. Clear? Done. These two sign conventions will play very crucial role. Then next, here when it comes to the electronegativity, here we are having the some electronegativity value. You have to remember. First one, hydrogen. Here it is a helium, right? Next, this is a lithium. Next one, beryllium, boron, carbon, nitrogen, oxygen, and the fluorine, right? Done. Next one, we are having the sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and the chlorine. Done. Now, if you remember these electronegativity values, what it will happen, you know, without any remembering of the any oxidation number of the atoms, you can say first one, here in the entire periodic table, the very important or the most electronegative element, and it is having the electronegativity values, that is 4, and from the 4 you just decrease 0.5. What you have to do from the 4, you have to decrease the 0.5. Here the fluorine 4, now the oxygen will be 3.5, right? The nitrogen will be 3. Then next, carbon will be 2.5, boron will be 2, beryllium will be 1.5, lithium will be 1, and the hydrogen, it is having some exceptional electronegativity value, that it is 2.1. Then next, for the sodium, from lithium to sodium, top to bottom, what happens? Electronegativity decreases. Now here 0.1 decreases. Now here to here you increase 0.3. Then it will be the 1.2. Here it will be the 1.5. Here it will be the 1.8. Here it will be the 2.1. Here it will be the 2.5. Just to increase the 0.4, sorry, and here it will increase the 0.5. Then it will become 3. Right? Next here it will be the bromine, right? Once I will write here. Bromine electronegativity value is 2.8, and side I will write here iodine electronegativity value will be 2.5. Clear? Now the AT also I will write, it may be used for you. Then it will be the 2.2. These are the some electronegativity values you have to remember. If you remember these electronegativity values easily in the application part of the chemistry, you will not get any mistake. Good afternoon everyone. Right? Now here, after the completion of the electronegativity values and the basics of the basics of the classification of the periodic table, now I am going to start the chapter redox reaction. Now in this redox reaction, the first concept, what is the meaning of the redox reaction and what we are going to study in this redox reaction. First of all, we are going to study about the oxidation state. What is the meaning of the oxidation state? Means real or assumed charge. What? The real or assumed charge. Real or assumed charge present on an atom in a substance. What? A molecule or atom or an ion. If assumed charge that it is present, then we call it as a oxidation state. Right? Now rules to calculate the oxidation state. Now how to calculate the oxidation states of the given atom or element, right? First one here, just directly I will explain from the periodic table so that it will be easy for you. First, second period elements, from that I will explain. For the second period element, this is a lithium. Now this is a beryllium. Now here it is a boron. Here it is a carbon, nitrogen, oxygen, and here it is a fluorine. And here it is a neon, and here it is a helium. Done? Now we know here the lithium contain only one valency electron. If you see here, the lithium atomic number is 3, so it is 1s2 and the 2s1. Here beryllium, it is having the 2 valency electron, 2s2. Now boron, it is having the 2s2, 2p1. Carbon, it is having the 2s2, 2p2. Nitrogen, it is having the 2s2, 2p3. Oxygen, it is having the 2s2, 2p4. And the fluorine, it is having the 2s2, 2p5. Right? Now here lithium, by the loss of one electron, what it will happen? It will reach to the helium electronic configuration. Now again, by the gain of 7 electron, it will reach to the neon electronic configuration. Right? Now every atom want to attain the noble gas electronic configuration or octet electronic configuration that we have studied. Now lithium, if it is readily lost the 1 electron, it will reach the duplet electronic configuration of helium. Now if it has gained the 7 electron, it will reach to the octet electronic configuration of neon. So for the lithium, loss of 1 electron is easy or gain of 7 electrons is easy. Loss of 1 electron is easy, right? Just now I said the loss of electron will be represented by the positive and the gain of electron will be represented by the negative. Done? Now lithium will readily lose the 1 electron so that it will reach to the helium electronic configuration. So that we can say entire helium electronic or this entire group 1 metals oxidation number will be the +1. Beryllium also same. Beryllium, it can readily lose the 2 electrons to reach the which one? Duplet electronic configuration. Now it will take the how many electrons? It will take the 6 electrons to reach the which one? Neon electronic configuration. So loss of 2 is easy instead of gaining of 6 electrons. So its electronic configuration will be +2. Sorry, not electronic configuration. Oxidation number will be +2. Now boron, loss of 3 is easy instead of gaining 5. Carbon, it can show +4 and the -4 depending upon the attachment of the electronegative element. Now when it comes to the nitrogen, oxygen and the fluorine, these three will play very crucial role. These 3 atoms oxidation number will play a very crucial role. Then why I was explained the electronegativity means here the oxidation number of these elements will be keep on changing. Why it is changing, that we will get to know by the attachment of the electronegativity element in that compound. Right? Now we'll see. Here nitrogen, how many electrons it will lose? Nitrogen, it can lose the 5 electrons to reach the helium, and neon to reach it is 3. Gaining of 3 is easy or loss of 5 is easy, but nitrogen can show +5 oxidation state as well as -3 oxidation state. Oxygen, it can show -2 oxidation state, and oxygen family will show the +6 oxidation state, and fluorine will always show the -1 oxidation state, and the fluorine or halogen family will show the +7 oxidation state. Why? It can lose the 7 electron, it can gain the 1 electron. Here it can gain the 2 electron, it can lose the 6 electron. It can gain the 3 electron, it can lose the 5 electron. Now these are the oxidation number of the elements. Then if you remember these oxidation numbers of these elements, now whatever may be the oxidation they may ask to calculate, we may not get any difficulty. Right? Now these are the first oxidation number of the elements that we have to remember. Then after that, next point, rules for calculating oxidation state. Rules for the calculating oxidation state. First one, oxidation state of an atom in its elementary state. Elementary state means if the atom is in elementary state. Elementary state means it's stable state. It means that it is a stable state. Elementary state, oxidation state of that atom, oxidation state of that atom is equal to 0. Is equal to 0. Sir, what are that elementary states of that atoms? Means oxygen, if they are given oxygen in the O2, its oxidation state is 0. Now fluorine, if they are given P4, its oxidation state is 0. If the sulfur, if they are given sulfur in the S8, its oxidation state is 0. If suppose nitrogen N2, if they are given, its oxidation state is 0. Okay. Now carbon, only simple carbon, diamond, if they have given, actually the stable state of the carbon is graphite. Okay, it is 0. But carbon will be exist in the diamond also, right? In the carbon, but as per the elementary state, its oxidation state is 0 only. But if suppose normally if they have given carbon diamond, what is the oxidation state of the carbon diamond? Means carbon diamond is also 0. Sir, how come, sir, carbon diamond 0 means in the carbon it is attached with the another carbon only. Electronegativity of carbon 2.5, another electronegativity of carbon is 2.5. See, sir, why these oxidation states are getting 0 in its stable state? If they ask, now comes to the year. Now EAN values will come. Done. Now you can see here the oxygen electronegativity value is 3.5. Done. Nitrogen electronegativity value is 3. Done. Now comes here. Here oxygen and oxygen will form the double bond, right? Done. Here this electronegativity is 3.5. This electronegativity is 3.5. So there is no any difference in electronegativity between them. So when there is no any difference between electronegativity between them, then its electronegativity value will be 0. Means there is no any higher electronegativity value or higher electronegativity atom to drag the electrons. When it is not having a chance to drag the electrons, both the oxidation numbers, clear, this is not getting any electrons, this is not getting any electron. That's the reason its stable state, oxidation states are 0. Right? Here also carbon graphite, Cc will be there. Carbon diamond also Cc will be there. Here 2.5, here 2.5. Both the state, oxidation states are 0. I hope it is clear for everyone. I hope it is clear for everyone, or you are getting any confusion. I hope it is clear for everyone. I hope it is clear for everyone. Yes, right. Now, this is the first rule. Now the second rule. The second very important rule that you have to remember is for the hydrogen. For hydrogen. Okay. Now, for the hydrogen, oxidation states, one, it is depending upon the attachment of the element it has been attached. Or if suppose hydrogen is attached with the group 1 or S block elements. Let's take better, we'll take the S block element. If the hydrogen is attached with the S block element, its hydrogen oxidation number will be the +1. Hydrogen oxidation state will be the +1. Right. If it is attached with the more electronegative atom than the hydrogen, sorry, here oxidation number is +-1. If it is attached with the S block elements, its oxidation number is -1. Clear? Now if it is attached more electronegativity atom than the hydrogen, if it is attached, its oxidation number will be the +1. Now, right, done. My dear friend Kushi, if you see the entire lecture, then you will get to know at the end of the lecture. Now here, sir, what are the examples for it? One, suppose if the lithium hydride and HCl will take, done. Here if suppose the lithium hydride, if they have given hydrogen oxidation number, they have given asking, and here the hydrogen oxidation number here asking. Here we know hydrogen electronegativity is 2.1, lithium electronegativity value is 0.9. Now the chlorine electronegativity value is 3, hydrogen electronegativity value is 2.1. Done. Here electronegativity difference we are getting, electronegativity differences we are getting. Then electronegativity differences if we are getting means there is chance of dragging the bond pair of electron towards itself. There is a chance of dragging the bond pair of electron towards itself. Now in this case, both the cases electronegativities are getting 0. Means there is no any chance of dragging the electron between the atoms. Done? Clear? Now here after that, which atom will get the electrons, which atom will lose the electron? More electronegative atom will drag the electron towards itself, and the less electronegative atom will lose the electron. Clear? Now the hydrogen being the more electronegative, it will drag the electron. Dragging of electron nothing but gaining of electron. Gaining of electron, it will get the -1, and the lithium will lose the 1 electron, and the lithium will get the +1 oxidation state. Now you can see, if the hydrogen attached with the S block, hydrogen is getting the -1 oxidation state. Now you see, if the hydrogen, if it is attached with the more electronegative atom than the hydrogen, chlorine is a more electronegative than the hydrogen. Then if the chlorine drag the electron towards itself, clear? Now the chlorine will get the -1 oxidation number. Now hydrogen will get the +1 oxidation number, right? This hydrogen will play very crucial role. You have to be very careful with this one. Done? Next. And the next very important for the oxygen. Next important that you are going to see for the oxygen, right? Most stable state or most stable state for the oxygen is O2. In this oxygen O2, oxidation state for the O2 is 0, that we have studied. Then most of the cases oxygen oxidation state is -2. Clear? Then if suppose only in the case of O2F2 and O2F2 and OF2, only in this case oxygen oxidation number is plus. Why? Because we know oxygen electronegativity value is 3.5, fluorine electronegativity value is 4. Then among the oxygen and the fluorine, which is more electronegative? Fluorine is more electronegative. Then just now the very key point I was explained to you. What is the very key point I was explained to you? More electronegative atom will drag the electron towards itself. Then fluorine being the more electronegative, it will drag the electron towards itself, right? Then here how many fluorines we are having? 2 fluorines we are having. Here how many oxygens we are having? 2 oxygens we are having. Then for 1 fluorine, if it is dragging the 1 electron from the oxygen, from the 2 fluorines, the loss of electrons from the each oxygen is 1. So here in this case oxygen oxidation state will be +1. Here why? Because if you want to calculate in the different manner also, I can explain. See, here 2 oxygens we are having, let us take it as a 2x. Now here the 2 fluorines we are having, take it as 2. How many electrons that fluorine is taking from the 2 oxygens? From 1 oxygen 1 electron, 2 oxygen 2, right? Then 2 into -1. Clear? The x is equal to +1 you will get. Plus. Then clear, here the oxygen oxidation state is +1. Here the oxygen oxidation state will be the +2. Done. In this case only in this case oxygen is bearing the +1 oxidation state as well as a +2. Most of the cases oxygen oxidation state will be the -2. But in some other cases, depending upon the nature of its oxides, oxygen oxidation states will be changed. How it will be changed? And these are the very important. You have to remember. Most of the cases they will not give you the formula. They will give you the names. Okay? By giving the name itself, you have to what? You have to identify the given compound. Then first one, peroxides. If they have given the peroxides. Now, in the peroxides, what is the oxygen oxidation state they will ask? What is the oxygen oxidation state in the peroxide? Peroxide formula H2O2. Done? Now, here you want to find the oxygen oxidation number, right? Right. 2 into, now we know oxygen is more electronegative, it is 3.5. Hydrogen is less electronegative, it is 2.1. Done? Then oxygen itself will take the electron. Then hydrogen will lose the electron, right? Already I explained it. If the hydrogen, if it is attached with the more electronegative than that one, its oxidation number will be +1. So oxidation state is +1. Then 2x is equal to 0. 2 plus 2x is equal to 0. X is equal to +1. In the peroxide case, oxygen oxidation state will be equal to +1. Done? Next one. Second one. In the second case, if they are asking in the superoxides, oxygen oxidation state. In the superoxide case, oxygen oxidation state. In the superoxide case, oxygen oxidation state will be the -1/2. Now the KO2 is a superoxide. Now this K will be comes under the alkali metal, right? Then here it is a +1 plus 2x is equal to 0. X is equal to -half. Done? Now this is a superoxide. Done? Next, third one. In the third case, ozonides. In the case of ozonides, that is KO3. Here its oxidation state will be the -1/3. Done? Here, now these are the some oxidation numbers, that your oxidation states of the oxygens you have to remember. Most of the cases oxygen oxidation state will be the -2, because depending upon the only attached element. But only in this case the oxygen's oxidation number will be the plus, and the remaining all the cases it will be the negative itself. Done? Clear? My dear friends, are you getting any confusion still, or is it clear? Still, are you getting any confusion, or is it clear? -1, sorry my dear friend, sorry, -1. Yes, thank you Subhana for saying it to it. If I take it to the 2 to the left hand side, it will become -2 by little plus, right. Thank you Subhana for it. Okay, now actually it is -1, right. I said it as a -1, but I wrote it as a +1. Okay. Next, if suppose polyatomic ions, if they have given polyatomic ions, if suppose if they have given the polyatomic ions, how to identify the oxidation state? What is the meaning of the polyatomic ion? Let's suppose something, this P4 -3 they have given. Now I want to calculate the oxidation state of the phosphorus here. I want to calculate the oxidation state of the phosphorus. How to calculate the phosphorus oxidation state? If they have given the polyatomic ion and as well as the charge on it, then how many phosphorus we are having? One phosphorus. 1 into oxidation state of phosphorus. We don't know. We have to calculate it. Then plus how many oxygens we are having? Oxygen 4, right? 4 into oxidation state of oxygen is equal to whatever may be the charge that is present on the ion, that you have to keep what you have to do, that you have to equate that oxidation state of phosphorus plus 4 into oxidation state of the oxygen equal to -3. In this manner we have to calculate the oxidation state of the phosphorus or oxygen, whatever may be they may ask in the question. In this manner we have to calculate it. Done. Let's suppose this is for polyatomic ion. Let's suppose something if they have given without charge molecule they have given. Let's suppose this is one molecule they have given. Then if you want to calculate the oxidation state of the sulfur here, then how to calculate? If you want to calculate the oxidation state of the sulfur here for a molecule, for a neutral molecule, this point is very important now. For a neutral molecule, oxidation state of all atoms is equal to 0. Done. Here how it is equal to 0? Now how to calculate? Now we'll see. Here 2 into oxidation state of hydrogen, because 2 hydrogens we are having, plus 2 into oxidation state of sulfur. Clear? Sorry, not 2. Sorry. Oxidation state of sulfur, because only one we are having. Only one sulfur we are having. 1 into oxidation state of sulfur plus 4 into oxidation state of which one? Oxygen equal to 0. In this manner we have to calculate the oxidation states of the neutral species. Done. Now I hope it is clear for everyone. Next one rule I will explain. After that I will give you the questions. One question I will explain and the remaining questions you have to do. Be ready for it. Now next, let B is more electronegative than let electronegativity of B is greater than A. Then if suppose single bond they have given like this, single bond they have given. Next suppose they have given the double bond. Suppose they have given the triple bond like this. Done. Then what is the oxidation number of the B and what is the oxidation number of the A? What is the oxidation number of the A? What is the oxidation number of the B? What is the oxidation number of A and what is the oxidation number of the B? If they ask, you have to see me how many bonds we are having here. In the first case only one bond. One bond contain how many electron? 2 electron, right? Then here this one electron is of the A and another electron is of the B. Then B, what it will do? B will drag, or B being the more electronegative, it will drag the A electron towards itself. When it is dragging the A electron towards itself, B will get the negative charge because gaining of electron. A is losing the electron, right? So it will lose the one electron, it will get the positive charge. Done. Next, here B, it is dragging one electron from the A and one electron from here. Total B is dragging the 2 electron towards itself. So it will get the -2 and it will get the +2. Now here the B, it is dragging the 3 electrons. Here it will get the +3. Sorry, here it will get the +3 and here it will get the -3. Right? If suppose, if they have given in this manner, the oxidation states you have to find out for the which one? If suppose if they have given the single bond, double bond and the triple bond in the given compound. Right. Now we'll start the question session for the underlined atoms. Okay, now I will write the compound. Now you have to say me the oxidation numbers very fastly. For the first one I will explain, and the remaining cases you have to find out. First one, if suppose K2Cr2O7 they have given. Second one, KMnO4, right? Right. Now, the third one, K2MnO4, right? Next. Fourth one, oxalic acid, H2C2O4, right? Now here one I will explain, and the second, third, fourth you have to say me. In the first case, here I want to calculate the chromium oxidation number, right? Now these all are the neutral species. If suppose the neutral species, what I said, sum of oxidation states of the all the atoms will be equal to the 0. So what you have to do, 2 into plus 1, because the potassium will comes under the group 1 metal oxidation number is plus 1. So 2 potassiums we are having, 2 into plus 1 plus 2 into chromium we have to find out. Let it as a, take it as X plus 7, and all the atoms which are attached here is less electronegativity than the oxygen. So its oxidation number is minus 2 is equal to 0. If you sum and if you simplify this entire equation or this entire, then what you will get here, the 2 plus 2x minus 14 is equal to 0. Now x is equal to plus 6 you will get. So chromium oxidation state is plus 6. Now what is the Mn oxidation state in the second one? What is the Mn oxidation state in the third one? And what is the carbon oxidation state in the fourth? Now be fast and say me very fastly. My dear friends, say me. Now in the first case, good, Vaishnavi, good. In the first case, oxygen oxidation number is 6. Okay, fine. In the second case, in the second one, what is the oxygen oxidation number? Oh, okay, Arav, whatever may be the doubt you are having, you can ask. Arav, you can ask, no problem. What is the doubt you are having? Now in the second case, magnesium oxidation number is plus 7. Now this is plus 1 plus x plus minus 2 is equal to 0. Now that x is equal to minus 8, if you say is minus 7, if you send it to the right hand side, it will become plus 7. Good, good. Yes, okay. Now the second case, 2x plus 2 into 1 plus x plus 4 minus 2 is equal to 0. Then it will become minus 6. Minus 6, if you send it to the right hand side, it will become plus 6. Here it is a plus 6. Now here oxalic acid. My dear friends, remembering of the names are also very, very important. This is oxalic acid. This is oxalic acid. You have to be very careful with this one. Oxalic acid, in the fourth one, what is the carbon oxidation number? In the oxalic acid case, what is the carbon oxidation number? What is the carbon oxidation number? Good, good, good. Now here the carbon oxidation number in the oxalic acid is plus 3. Because 2 plus 1 plus 2x plus 4 minus 2, if you do, you will get the answer. Right. Okay, fine. Now, next one. Next molecules we'll see. Fifth one, N minus 3. Sixth one, SO2. Now, in the seventh one, NO2. Right. Next, eighth one, N2. Ninth one, CO3 minus 2. Next, 10th one, NH4 plus. Next, 11th one, C2H6. 12th one, CH4. Now, 13th one, C6H12O6. Now, start sim. What is the answer? Now, what is the answer for this question? Seventh one is plus 4. Sixth one is plus 4. Fifth one is minus 3. Good. Here it is a minus 3. Charge on the atom is the oxidation number. Charge on the atom is the oxidation number for the given species. Right? Now, charge on the atom will be the oxidation number for the given species. Here it is a plus 4. Here it is a plus 4. Eighth one. Eighth one is 0 because it is present in its stable state. Ninth one, carbon, nitrogen, carbon. No. Ninth one, carbon. Ninth one is 4. Here X plus 3 minus 2, right? Here carbon, it is a minus 6. Minus 6, if you send it to the right hand side, it will become plus 6, it will become plus 4. Yes, ninth one is plus 4. Tenth one, it is a minus 3. Okay, good. 10th one, it is a minus 3. 10th one, it is a minus 3. Okay, good. Next. 11th one is also minus 3. It is a plus 6. If you send it to the right hand side, it will become the minus 6. Minus 6. After that, if you add by 2, right? This minus 3. Good. 11th one is also minus 3. 12th is minus 4. Good. 12th is minus 4. Eleventh, you are having doubt. Why doubt? This is 2x, right? 2x plus 6 plus 1 is equal to 0. If you send it to the right hand side, it will become 2x minus 6. If you send it to the x is equal to 6 by 2, it will give minus 3, right? Minus 3. 13th it is 0. Good. 13th it is 0. Now here next we are going to see some exceptional oxidation states of the given compounds. Some compounds will have, when we have calculated from the, which one? When we have calculated from our general oxidation state which we are calculating, we will get different oxidation states. First thing in that one, if you take the oxy acids, that is H2SO5, next CrO5, done. Next one, and next one H2S2O8, done. Next Fe3O4. This type of the molecules they have given. Then they will ask you what is the oxidation number of the sulfur, what is the oxidation number of the chromium, what is the oxidation number of the sulfur, and what is the oxidation number of the iron. Done. Can anyone say me what is the oxidation number of the sulfur in the first one? Can anyone say me what is the oxidation number of the given species? If you know, say me. If not, I will explain. Are you there? Give me the question mark. I will explain if you don't know. See, here this one is a Carus acid. If you calculate from the general oxidation state calculation, if you do, what you will get? +2 and -10. +2 -10, x is equal to +8 you will get. +8 you will get, right? But here we know already I explained you very clearly. What I explained very clearly here when it comes to the this is oxygen and the sulfur, right? Oxygen and the sulfur. This is the oxygen family. Maximum to maximum it can lose the 6 electron. Minimum to minimum it can gain the 2 electrons. Means entire oxygen family oxidation state will be either it should be in the +6, either it should be in the -2. In between -2 to the +6 it should be there. But when you calculated the oxidation state from it, you got it as a +8, which it is not at all possible. Then here also chromium electronic configuration is argon 4s1 3d5. So maximum to maximum chromium can lose only 6 electron. If you calculate it from here, you will get it as a how much? +10 oxidation state. Then here also sulfur 2 + 1 + 2x + 8 - 2. Here +2 and here it is a -16. +2 -16 it will become -14. -14 by the 2x, x is equal to +7 you will get. But sulfur maximum oxidation state is a +6. Now Fe3O4. If you calculate it from here, you will get it as a 4 - 2. That you will get it as a fractional oxidation state, that is 8/3. Done. Now actually sulfur should lose the 6 electrons. Then we have to consider that these all are exhibited in the some other manner. What is the some other manner it has been exhibited? Because here this H2SO5, it has been existed in the nature in the some other manner like oxy acid. It is exhibiting the oxy acid structure. Sir, how to identify the oxy acid structure means? Now I will explain. Listen. Normally the sulfur valency electrons are 6, right? Sulfur valency electrons are 6. Then oxygen maximum valency electrons are 6. Then this oxygen to complete its octet, it required 2 electron. Now it will take the 2 electron from the sulfur. Done, right? In real, how many oxygens we are having? Left 4 oxygens after the forming of this bond. Then another oxygen, it will form the bond with this oxygen. Done, clear? Now next, remaining what we are having? 3 oxygens left and 2 hydrogens left, right? One oxygen, it will form a bond with hydrogen, and another oxygen, it will show the peroxy linkage as well as the bond. Now this is a H2SO5. This is the structure of which one? H2SO5. Now you see here sulfur and oxygen, which is more electronegative? Sulfur and oxygen, which is more electronegative? Sulfur and oxygen, which is more electronegative? Can anyone? Sulfur and oxygen is more electronegative, right? Now you can see sulfur is losing how many electron? 1 electron from here, 1 electron from here, 1 electron from here. Sorry, peroxy linkage, right? Peroxy linkage means here the 2 electrons will be there. Coordinate covalent bond. Here this one double bond, right? Here from 2, here from 2, here 1, here 1. Total it is a +6 oxidation state. I hope it is clear, or should I explain once again? Should I explain once again, or should I move to the next question? Should I move to the next question, or should I explain once again? Should I repeat it? My dear friends, should I repeat it? Should I repeat or should I move? Next question. Okay, done. Next, CrO5. The next one we are having the CrO5, right? Next. In the CrO5, here the chromium, it will be exist in the form of the butterfly structure like this. It will be exist in the form of butterfly structure. Right? Now with the same question I will explain with the another example so that it will be clear for you. Now CrO5, now you can see here chromium is losing how many electron? Chromium is losing how many electron? Total 5 electron, right? Here 2, here 3, here 4, here 5, here 6. So its oxidation number will be the +6. Now next one we are having the H2S2O8. Here the sulfur maximum to maximum, it will form the 6 bonds, right? Now sulfur double bond O and one double bond O and one oxygen with OH, right? Next oxygen and another oxygen. Now here the sulfur, again the double bond O, again the double bond O, and here it is a OH. Now you see sulfur has formed the 6 bonds, right? 1, 2, 3, 4, 5, 6. Here also sulfur has formed the 6 bonds, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Right? How many oxygens we are having? 8. 8 oxygens are there. 1, 2, 3, 4, 5, 6, 7, 8. Clear? And how many hydrogens we are having? 2 hydrogens. Each hydrogen will form the single bond, we know. Right? As well as after that, next each oxygen will form only the double bond, that we know. Right? Each oxygens are forming the double bond and its octets are completed. Every in the each and every compound, octets of the molecules has been completed. Done. Now what we have to do, we have to calculate the oxidation states. Now you see, oxygen is a more electronegative, it will take the bond pair of electrons. Now sulfur, it has formed the 6 bonds, so it has losing the 6 electrons, its oxidation number is plus 6. Now here also its oxidation number is plus 6. That's it. Now with the help of the oxy acids, we have to identify, or we have to say which oxidation state or which oxidation number it is having. Clear? Now next, suppose mixed oxide Fe3O4, if they have given. In the Fe3O4, in the question, if the sum of oxidation state, if they ask, or average oxidation number, if they ask, average oxidation number of this compound is 8.8 by 3. But if suppose sometimes in the question they will ask what are the mixed, or how many oxidation state in the Fe3O4 that iron can exhibit. So iron will be exist in this nature or exist in this compound as a FeO and Fe2O3. Fe2O3. In this manner it will be exist in the nature. Then in the first one, its iron oxidation number is plus 2. Now in this case the iron oxidation number will be the plus 3. Right? Done. Next one. This is some mixed oxide question. The second type of the mixed oxide question, they may ask 8 by 3. Now the second mixed oxide question they may ask, that is a Ki3. That is Ki3. Now in this Ki3, if you calculate the oxidation number, you will get it as a minus 1 by 3. Minus 1 by 3. But this Ki3 will be exist in the nature as a Ki as well as I2. As well as I2. Then here in the Ki, iodine oxidation number is minus 1. And here the iodine oxidation number is a which one? 0. Because it is present in its stable state. Next. The next very important molecule that we are going to see, that is IPO. That is IPO. Na2S4O6. Na2S4O6 is the IPO. Then what is the sulfur oxidation number? Not, this is not the Now this one they may give like this also. S2O3 minus 2. S2O3 minus 2 also they can give. Now what is the oxidation number of the sulfur here? What is the oxidation number of the sulfur here? Sorry, this is the IPO. Sorry, this is the IPO. Na2S2O3. Not, this is not the IPO. And what is the sulfur oxidation number here? What is the sulfur oxidation number in the S4O6 minus 2 and S2O3 minus 2? What is the oxidation number of the sulfur in this case, and what is the oxidation number of the sulfur in this case? Now can anyone say me? Can anyone say me what is the oxidation state of the sulfur in the first one and the second one? In the first one and the second one. In the first one, what is the sulfur oxidation state, and then the second one, what is the sulfur oxidation state? What is the oxidation states you are getting? First one you are getting it as a 5 by 2. Okay. First one you are getting it as a 5 by 2. First one you are getting it as a 5 by 2, but the 5 by 2 is not the answer. See, not here this sulfur Na2S4O6 will be exist in this manner. Sulfur will form the how many bonds? 6 bonds, right? Now here it is a minus. Now sulfur, sulfur, and here it is a double bond O, and here it is a double bond O, and it is a minus, right? Now you can say here sulfur is losing the how many electron? 1 electron, 2 electron, 3 electron, 4, 5. But because here the sulfur is not losing any electron, because here the sulfur and sulfur is both same. Both the cases sulfur and sulfur electronegativity is same. Only here it is a electronegativity is 3.5 and this electronegativity is 2.5, right? So oxygen being the more electronegative, it will taking the 2 electrons. Here the 2 electron, here 1 electron. So 1 sulfur oxidation number is plus 5. Here the 1 sulfur oxidation number is plus 5. They may ask what is the oxidation numbers of the sulfur which is present in the internal sulfur. This is 0 and 0 because both the cases all the carbons are same. All the sulfurs are same. Electronegativity is 0. Now in the second case it will be the 2x plus 3 minus 2 minus 2. Here minus 6. If you send it to the left hand side it will become plus 6. Then x 2x is equal to plus 4. X is equal to plus 2. Here its oxidation number is plus 2. Done? Right. Next. And the next very important, they may ask for you in your questions to make you confused. Suppose, like this, if they have given H2O2 oxygen oxidation number and Na2O2 oxygen oxidation number, strontium peroxide Sr2O2 oxygen oxidation number, and the barium peroxide BaO2 oxygen oxidation number. Now can anyone say me? Now in all the cases in the peroxy structures, in all the cases oxygen oxidation number is -1 only, because this one will be exist in the nature. Actually this will be exist as a structure, as a open book like structure, but we are talking about only the oxidation states, right? So I was showing how the oxidation state of the H2O2 has came. Now in the Na2O2 also it will be exist in this manner only, Na and it is a Na. But if suppose if they are given the strontium oxide, strontium oxidation number is +2, then strontium will form the one peroxy linkage in this manner. Here it is a -1 and here it is a -1, but strontium is losing the 2 electrons, right? So it is +2. Barium also same. Barium peroxide, if they ask also, barium peroxide will be in this manner. Now here it is a -1, here it is a -1 and here it is a +2. I hope it is clear for everyone. Now next, if suppose if they have given the potassium superoxide, that already I was discussed very clearly. Next, some different oxidation are some. Next we are going to see the fractional oxidation states of the some compounds. What are the fractional oxidation states that we are having? The first one we are seeing fractional oxidation states of the given compound. In the fractional oxidation state of the given compound, first one is a S4O6 - 2. Just now we have seen in the S4O6 - 2 the fractional oxidation state of the sulfur. This is O minus. Now this is sulfur, sulfur, double bond O and the double bond O, and this is a O minus. Now here we are having the +5 and the +5. Clear? Now if you calculate averagely, you will get it as a 5/2 is the oxidation state. Done? Now next one. The next one, this is name of this compound if they have given tribromo. Now next, sorry. Now here the not tribromo. The next compound we are going to see. Next compound we are going to see C3O2, carbon suboxide. If suppose if they ask what is a carbon suboxide, my dear friends, this is a repeated question. in your exams, most of the cases they are asking, what they are asking, you know, what is the oxidation state of middle carbon? They are asking the question in this manner, what is the oxidation state of the middle carbon in this compound? Then without knowing the structure of this compound, we may not predict the middle carbon's oxidation number. So first of all, we know carbon will form the 4 bonds, right? When the carbon is forming the 4 bonds, here how many carbons we are having? 4 carbons we are having, right? Sorry, 3 carbons we are having. Write the 3 carbons in this manner. Then after that, we know 2 oxygens we are having. Each oxygen will form the double bond. So this carbon double bond O and this carbon double bond O. Done. Now here this carbon left over, it will form the 2 bonds, and this middle carbon, it will form the 2 bonds from here, and this middle carbon, it will form the 2 bonds from here. Now this is the carbon suboxide. Now you can see all the octets of the atoms which they are present in the compound has been completed. Done. Here you can see oxygen. Now here the oxygen octet has been completed. Carbon octet also completed. 1, 2, 3, 4. 1, 2, 3, 4. Octet completed. Here this one oxygen also. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All the atoms what it has been completed? Octet has been completed. Now you say me this middle carbon oxidation number. Now you say what is the middle carbon oxidation number in this compound? What is the middle carbon oxidation number in this compound? My dear friends, say me what is the middle carbon oxidation number in the central atom? Central carbon oxidation number. If you know, say me the S. If not, give me the question mark. Okay na? If you know the answer, say me. If not, give me the question mark. Anyone? Anyone who is in live, should I explain? No. Now the middle carbon oxidation number is 0. Because already I explained, no. Why you are getting confusion? This carbon oxidation number is 2.5. Sir, carbon electronegativity is 2.5. Now this carbon electronegativity is 2.5. Done. Now if this carbon electronegativity is 2.5, then the middle carbon electronegativity is also 2.5. Then here the carbon electronegativity 2.5. Here the carbon electronegativity is 2.5. This carbon electronegativity is also 2.5. Now if the electronegativities of the both the carbons are same, then this carbon will not drag the electrons towards itself. Now this carbon, it will not drag the electron towards itself. Then middle carbon is not having chance to loss of its electron. Then whatever may be the electrons it is having before, the same electrons will be with that middle carbon only. It is not losing the electron, it is not gaining the electron. If both are not loss of the electron and the gain of the electrons, if it is happened, now the central carbon, middle carbon oxidation number will be 0, right? Why you are getting confusion? Right, I hope it is clear for you. Middle carbon oxidation number is 0. Now comes to the carbon number 1. This is carbon number 2 and the carbon number 3. If you comes to the carbon number 1, carbon number is losing the 2 electrons towards oxygen, because oxygen, it is being the more electronegative. so it will lose the 2 electrons, so its oxidation number is minus 2. Here it is losing the 2 electrons, its oxidation number is minus 2. Now here the X will be, what is the X here? 4 by 3. 4 by 3. Okay, done. That's the reason I am saying you very clearly the oxidation numbers and the electronegativity values also. I explained it very clearly in the starting. Electronegativity values will play very crucial role. Depending upon the electronegativity values only, you can easily identify the oxidation states of the given elements or given atoms. I hope it is clear. Next, if suppose they have given in this manner, Br3O8 they have given, Br3O8 they have given, then if suppose the Br3O8 they have given, they will ask you what is the oxidation state, what is the oxidation state of middle bromine, what is the oxidation state of the middle bromine, they will ask. Middle bromines, what is the oxidation state? What is the oxidation state of the middle bromine? Now bromine maximum valency electrons are 7, right? Bromine maximum valency electrons are, this is 35 atomic number. Atomic number 35 means this is a 4s2 4p5, total 7 electrons. Now bromine, one bromine contain 1 2 3 4 5 6 7, right? Another bromine also will contain 1 2 3 4 5 6 and one extra electron, that is 7. Now the another bromine will contain, no, you may think that it is 0, but it is not the 0. Now you see, clear? Now the 3 bromines I was written. Now oxygen, how many oxygens we are having? 8 oxygens. Each oxygen will form the double bond like this. Then each oxygen will form the double bond. Next, here the bromine and bromine will form the single bond, right? Another 2 oxygens will form the double bond with this one. Now this is a one odd pair of electron and this is a one odd pair of electron, right? Now here you can say this middle bromine is losing the 4 electrons, right? Middle bromine is losing the 4 electrons means here its oxidation number will be the 4. Now what are the oxidation number for the first bromine and third bromine? Now what is the oxidation number of the first bromine and the third bromine? Yes, good, Subhana good, Amma, Vaishnavi good. Now say me the what is the oxidation number for the first bromine and the third bromine? What is the oxidation number for the first bromine and the third bromine? What is the oxidation number of the first bromine and the third bromine? Good. It is a +6 and here it is a +6. +6 and the +6 is a oxidation number of the which one? Bromines that are present in at the terminal position, right? I hope it is clear for you how to identify the oxidation numbers for the given species. Done? I hope it is clear for everyone, or still you are getting any confusion? I hope it is clear for everyone how to identify the oxidation numbers of the given species. Next, one very important next type of the oxidation numbers they may ask, that is a fractional oxidation number or the non-stoichiometric oxidation number. If suppose if they have given the FeO or Fe, sorry, if suppose if they have given the one non-stoichiometric compound like this, Fe 0.95 and O, if suppose if they have given in this manner, then how to identify the, they will ask you identify the oxidation numbers of the iron which are present in the +2 and as well as the +3. Clear? We know it is in the form of the mixed oxide type. This non-stoichiometric compound they have given, they are asking calculate the percentage of Fe+2 and percentage of the Fe+3. Calculate the percentage of the Fe+2 and Fe+3 that is present in this non-stoichiometric compound. So whenever this type of the non-stoichiometric compound they have given, what you have to take here, how much percentage of this Fe+2 is present in this non-stoichiometric compound and how much percentage of this Fe+3 that is present in this non-stoichiometric compound, we don't know. So that's the reason what you take Fe+2 if they have given, and here it is a Fe+3, right? This Fe+3 take it as the X, right? Now here it is in the form of the non-stoichiometric, right? First what you do, make the non-stoichiometric compound into complete number. To make it as a complete number, what we have to do, we have to multiply this entire compound into the R. We have to multiply into 100. If you multiply with the 100, it will, what it will become? It will become 95 and oxygen will become 100, right? Now in this non-stoichiometric compound, we are having the 95% of the iron and 100% of the oxygen. If suppose in this 95% of the iron, how much Fe+2 we are having, how much Fe+3 we are having, we have to calculate. So Fe+2 oxidation state, take it as a X. Then how much X value if we get, if you minus it from the 95 minus XY, because iron we are having 95%. In this 95%, if you get the X means, if you minus the X from this 95, you will get the Fe+3. Then how to identify for this one? Just same thing. Find the entire compound oxidation number. That you will get the X. How? X here, how many? What is the oxidation state of the Fe+2? 2, right? So 2x plus oxidation number of the Fe+3 is 3, and it is present in that compound, or its oxidation number, if you take it as, it will become 95 minus X plus 100 minus 2 is equal to 0. Then if you calculate X, you will get it as a 85. Then X, if it is 85, then 95 minus X will give you the 10%. This is 10% it is present, and it is 85% it is present in the compound. Clear? Now next, if suppose if they have given this like this, titanium O 1.1, calculate the titanium +2 and titanium +3 that present in the compound. If suppose if they have given in this manner, again what I said, the non-stoichiometric compound, make it into the complete number by multiplying that into 10. If you multiply with the 10, it will become the titanium 10 and it will become the O11. Clear? It will become the O11. Now this titanium, which it is multiplied with the 10, it has become the 10%. In this 10% of this titanium, we are having the +2 oxidation state and it is having the +3 oxidation state. Now how much is the +2 oxidation state? How much we are having in the +3 oxidation state? We have to calculate. Same thing. Take it as a X, and this one will be the 10 minus X. Right? After that, you have to find out the X. How? First, you have to multiply, or you have to add sum of all the component that is present in this compound. Here, how much is the titanium oxidation state? +2, and it is percentage. How much it is having? X. So 2x plus 3 into 10 minus x plus 11 minus 2 is equal to 0, because oxygen is also having, right? Oxygen is also having. This is present Ti 10 in that plus 2 percentage and it is in the plus 3. How much it is there? If you take the Ti plus 2 as a x, 2x, and the Ti plus 3, 10 minus x, 3 into 10 minus x plus 11 minus 2. Done. Then the x value you will get it as 8, and another you will get it as, if you get it as a x, then titanium plus 3 will get it as a 2. Done. I hope it is clear. I hope it is clear for you. One question I will give you. Now you have to say me the answer. For this one, you have to say me the answer. This 2, I think so, it is clear. If suppose the fractional oxidation states, if they have given, how much percentage of the Fe plus 2 and how much percentage of the Fe plus 3 they have given, how to calculate? If suppose if they have given, now you have to say me the answer for this one. The copper, if it is in the form of, in this manner. Okay? Now, calculate percentage of Cu plus 2, calculate the percentage of Cu plus 2 and Cu plus 3. Same. Calculate the percentage of Cu plus 2 and Cu plus 3 in the compound. Fastly. Same thing. Make the fraction into complete number. After making the fraction into the complete number, take this whatever may be the complete number, after getting that much percentage or that much percentage of the carbon it is present in that compound. In that, one is present in the Cu plus 2, one it is present in the Cu plus 3. So say me how much is the Cu plus 2, how much is the Cu plus 3. Fastly. If you are not getting the percentage Cu plus 2 by Cu plus 3, then you can do it or calculate Cu plus 2 by Cu plus 3 then. Calculate the Cu plus 2 by Cu plus 3. If you are getting the answer in the minus, then calculate the Cu plus 2 by Cu plus 3. Cu plus 3 is 1.5. No, make it as a complete number. Now you can see here the Cu 1.95 into O. Then if you multiply it with the 100, if you multiply with this 100, then it will become the Cu 195 and the oxygen into 100. Done. Now this Cu, it is exist in the nature as a Cu plus 2 and one will be exist in the Cu plus 3. Right? Now here if you take it as a, this is a 2x plus 3 into 195 minus x plus 100 into minus 2 is equal to 0. Done. Then you will get it as, how much you will get? 3 into 195. 3 into 195, here it is a 2x and minus 3x, you will get it as a 585. 585 minus 100 into 2, it is 200 and it will get as a minus x is equal to 0. Minus 200 you will get as a minus, you will get it as a 385. If you send it to the left hand side, minus 385, x is equal to 385 you will get. How much you will get? X is equal to 385 you will get. Then x is equal to 385 and 195 minus 385. How much you will get? 385 you will get. 385 minus 195. 190 you will get. Cu plus 3 you will get it as a 190. One is 385. One is 190 minus 190. Then if you divide it, how much you will get? How much you will get? One is 385, one is 390. That only I am asking. If you divide it, how much you will get? X and the plus 3. $190. Cu plus 3 you are getting it as the negative. Okay, then better you try with the in this manner. Instead of plus 3, try with plus Cu plus. Once you try with the Cu plus, then if you are getting the answer in the negative means, okay, we'll do the question with the negative. Cu 1.95 O, calculate the Cu plus 2 by Cu plus. On negative you are getting, right? Answer you are getting in negative, but answer should not be in the negative. Once you try with the Cu plus 2 by Cu plus 1, my dear friends, once you try with the Cu plus 2 by Cu plus 1, once you try the answer Cu plus 2 by Cu plus 1, once you try with the Cu plus 1, with plus 1 you try. Cu plus 2 by Cu plus 1 you try. Are you trying? Are you trying Cu plus 2 by Cu plus 1? $38 you are getting. Okay, we'll see here. Cu 1.95 O into 100, if you do, you will get it as a Cu 195 and oxygen 100. Now this is present in the Cu plus 2 and this is present in the Cu plus 1. Now Cu plus 2 means, let's take it as a x, and 1 will be the 195 minus x. Then 2x plus charge is 195 minus x minus plus 200 into minus 2 is equal to 0. This much, how much you will get? So x is equal to 5 you will get. X is equal to 5, which is present in the Cu plus 2, you will get it as a 5%. Then Cu plus you will get it as a 190%. Then Cu plus 5 by 90. 5 by 90 you will get. 38 how you will get, amma? I asked you to calculate the Cu plus 2 by plus 1. So here the charge is plus 1, right? 2x, here the charge is 2x, and 1 into 1, if you take it as a x, then it will be the 195 minus x. 2x, 195 minus x plus 100 into minus 2. It will become 2x 195 minus x. 2x minus x, it will become x, and it will become minus 2, 200. 195 minus 200, it will give you the, how much it will give? It will give you the minus 5. Minus 5, if you send it to the left hand side, it will become plus 5. So x is 5, then Cu plus 1 will be the 190. 5 by 190 will give you the answer. I hope it is clear. Or still you are getting confusion? Are you getting any confusion? Five by 190 will give you 38. 5 by 190 will give you something 0.026, right? Something it will give 0.026. I am asking by Cu plus 2 by Cu plus 1. Cu plus 2 I got it as 5. Cu plus 1 I got it as 90. Okay? Right. Done. Next one. The next concept that we are going to study, the which one? Oxidation and the reduction. Okay? The next concept we are going to study, that is the oxidation, and the next is the reduction. First of all, what is the meaning of the oxidation? Oxidation means addition of oxygen, right? Now here the reduction means addition of hydrogen. Second one, what is the meaning of oxidation? Removal of hydrogen. Now, here what? Removal of oxygen. Removal of. Done. Today I am thinking to finish the chapter. Okay, let me try. Until when? Until 6 I will continue. Okay, until 6 I will continue and I will stop, because I am thinking you to what I am thinking means to complete the mole concept. To complete the redox reaction today, so that tomorrow we'll do the direct questions. The complete questions we can do, because on Monday we are having the exam, right? So that it will be clear for you. And the mole concept also I have to cover. And the tomorrow morning also I will take the class, and the question session I will start at evening, same time, the 3:30, like that. Up to 6 I will continue. Okay, until 6 how much content it will be completed, that much I will teach, and the leftover content I will continue tomorrow. Tomorrow I will update the time for you. In the time we'll start the remaining content, and the question session we will do at the evening, right? Okay, fine. Now addition of hydrogen, and the third one, this is addition of electronegative element. Now here removal of electronegative element. Done. Next, very important point, that is a loss of electron is nothing but oxidation. Loss of electron will be indicated by positive. Now here fifth one, it is a gain of electron. Gain of electron indicated by the negative. Done. Clear. Here the next very most important point that we are going to thermodynamics I will start tomorrow for the MSET people. For the MSET people, the thermodynamics questions I will update you in the Instagram tomorrow. Okay. When will be the thermodynamics question session? Thermodynamics question session I will update you in the Insta tomorrow. Done. Next, the next very important point that we are going to see, that is a oxidizing agent. My dear friends, many of the students, they will get confused here itself. What is the meaning of the oxidizing agent and what is the meaning of the reducing? Oxidizing agent means itself reduce and oxidize others. Itself reduce and oxidize others is known as the oxidizing agent. Next, what is the meaning of reducing agent? What is the meaning of the reducing agent means? The reducing agent means itself oxidize and reduce others is known as the oxidizing agent. Done. Let's take one reaction to clearly to understand which is oxidizing agent, which is a reducing agent. Now let's suppose I was taking the one reaction, general reaction, Zn plus 2 and the Cu, right? Now you can see here in the Zn, it is present in its native state, its oxidation number is 0. Now here the copper, it is present in the plus 2 oxidation state. Then here the zinc, it has present in the plus 2 oxidation state. Now the copper, it is present in its native state, it is 0. Done. Now it is aqueous, this is aqueous. Done. Here you can see from the zinc, from the plus 2 oxidation state, from the 0 oxidation state, it has reached to the plus 2. Now plus means I said you loss of electrons, right? Now plus indicates that loss of electron. How many electron it has lost? Zinc 2 electron it lost. Loss of electron is nothing but oxidation. Now zinc has undergone the oxidation. Now you can see copper has gained the 2 electron because from the plus 2 it has reached to the 0 means gaining of electron is nothing but reduction. Copper has undergone the reduction. Copper has undergone where? Reduction. Now if the copper undergoes the reduction, then zinc undergoes the oxidation. Which is the oxidizing agent and which is the reducing agent, they will ask. Then zinc, by the loss of electron, it has undergone the oxidation, means zinc is acting as the reducing agent. Sir, how sir it is acting as a reducing agent means? What is the main definition of the reducing agent? What is the main definition of the reducing agent? Straight, itself oxidize and reduce others is a reducing agent. See, zinc from the 0 to plus 2 it has went. So itself it has been oxidized. How many electrons zinc has lost? 2 electron lost, right? The 2 electron was gained by the which one? Copper. So Cu plus 2 is acting as a oxidizing agent. It is acting as a oxidizing agent. I hope it is clear. Oxidizing agent. Now you see, whatever may be the electrons of the zinc has been lost, that it was gained by the copper. Now the copper, it has gained the 2 electrons, it has decreased its oxidation number. Done. So zinc has gained the 2 electron, zinc has lost the 2 electrons, so reducing agent. Now copper has gained the 2 electrons, so oxidizing agent. Itself reduce and oxidize others. Oxidizing agent. Itself reduce and oxidize others is known as the oxidizing agent. Clear? Here the Z is reducing agent, oxidizing agent. Next. Here, instead of identifying in the reaction, I will say you one trick to identify which is oxidizing agent, which is a reducing agent, how to identify among the given species which is oxidizing, which is a reducing. First one, here minimum oxidation state, minimum. Next, intermediate oxidation state. Next, maximum oxidation state. Now, based on this one, we can identify which one is a oxidizing agent, which one is a reducing agent, which one will be act as both. If the central atom present in minimum oxidation state, it act as reducing agent. Blindly believe it. Minimum oxidation state means it can readily lose the electron, but it will never take the electron. Then the maximum oxidation state means if a central atom present in maximum oxidation state, it act as oxidizing agent. Means it can readily take the electron, but it will not lose the electron. Right? If it is present in the intermediate, intermediate means it can act as both oxidizing agent and reducing agent. Yes, Praneeth? Yeah, Semi Praneeth. Now, here H2SO4, if they have given H2SO4 will act as oxidizing agent or reducing agent. Oxidation state of the central atom. Done. Next, maximum oxidation state. Next, minimum oxidation state. And the nature. Here in the H2SO4, if you want you can listen. Then I will ask the questions in between. Try to say me, because this redox reaction will be helpful for you for your D and F in the second year. You can continue, no problem. Now, right now, central atom in the H2SO4, central atom oxidation state is +6, right? Maximum oxidation state of the sulfur is +6 and minimum oxidation state is -2. Now, here in the H2SO4, if it is present in its maximum oxidation state, what is the nature of H2SO4? You can wish, yours wish. Now, the one who was in the live, once you say me, H2SO4, what I said, this if you remember, if the central atom present in maximum oxidation state, it will act as a oxidizing agent, Then, if the central atom present in minimum oxidation state, it will act as a reducing agent. If it is present in intermediate between minimum and maximum, then it will act as a both oxidizing agent as reducing agent. Now, same here. H2SO4, here it is present in the maximum oxidation state. What is the nature I am asking? Nature means it is acting as oxidizing agent or reducing agent, or it will act as both. What is the nature of this oxide? That is strong oxidizing agent, because it is present in its maximum oxidation state, right? So it will act as a strong oxidizing agent. Done. Next one. Next, let's suppose if they are given H2S. Now, sulfur oxidation number here it is a -2. Maximum oxidation is +2, minimum oxidation number is -2. If it is present in its minimum oxidation number, then what it will act? then what it will act? Fastly, be fast. Oh, this is strong reducing agent. Done. Now, next, if suppose H2SO3 they have given. Now in the H2SO3, the sulfur oxidation number is +2 and the -6, it will become +4. Then maximum is +6, minimum is -2. Now you see, S2O3 is present in its minimum oxidation state. If it is present in its minimum oxidation state, it will act as a both. Sorry, intermediate oxidation state, it will act as a both, because +4 is present in between -2 as well as a +6. So that's the reason it will act as a both. Then if suppose SO2 they have given, SO2 is also +4, +6 and -2, it will act as a both. So in this manner you can easily identify in the given species whether it is an oxidizing agent or whether it is a reducing agent. Next, this is about the sulfur. Now we'll go for the nitrogen. Now for the nitrogen also NO3. Now here the nitrogen oxidation number is +5. Central atom oxidation state is +5. Maximum oxidation state will be +5 and minimum oxidation state is -3 for the nitrogen. Then what is the nature? Nature you can see maximum oxidation state is +5. If it is present in the maximum oxidation state, maximum to maximum nitrogen can lose 5. Again it will not having chance to lose the 5 electrons. It can readily gain the electrons, means it will act as an oxidizing agent, strong oxidizing agent. Done. Now comes to the ammonia, NH3. Comes to the NH3. In the NH3, nitrogen oxidation number central atom is -3. Maximum it is +5, minimum it is -3. Then minimum oxidation number it is -3. When the minimum oxidation number, if it is a -3, then what? It can readily gain the electron or it can readily lose the electron? It can readily lose the electron because maximum electron capacity it has gained. So it is readily lost the electron, right? Strong reducing agent. Done. Next, let's suppose if they have given the HNO2. Now HNO2 if they have given nitrogen, it is +2 and a +1. +1 and the -4, it will become +3. In the HNO2, nitrogen central atom oxidation number is +3. Then maximum it is +5, minimum it is -3. Then it is present in the intermediate, right? Intermediate means it will act as a both oxidizing agent and the reducing agent. Clear? I hope it is clear for everyone. I hope it is clear for everyone. I hope it is clear for everyone. Done? Right. Next we are going to see the types of reactions. The next types of the various types of the redox reactions that we are going to see. Now, what are the various types of the redox reactions that we are going to see? First one, various types of redox reaction. The various types of the redox reaction. First one is a intermolecular redox reaction. What is the meaning of the intermolecular redox reaction? Inter means, my dear friends, you have to be very careful with the inter. Inter means the one substance undergoing oxidation and other going reduction. Okay, inter means one is undergoing oxidation, one is undergoing one oxidation, one reduction is known as a intermolecular redox reaction. Example, if suppose Fe in the presence of hydrazine N2H4, it will give you the NH3 and it will give you the ferrous hydroxide, right? Done. Now here you can see what is the oxidation number of the iron here. Iron, it is present in its stable state, its oxidation number is 0. Now here the nitrogen oxidation number is -2. Done. Here in the nitrogen oxidation number, here it is a -3. Now here the iron oxidation number is a +2. Sir, how it has become the +2 means already it is present in the, already I explained very clearly that it is in the form of the AX/BY type. Here the X is 1, B is 2. Then how it will be dissociated? It is dissociated as a X A power Y plus Y power Y into B power X minus, right? Done. Here the X is 1 and Y is +2. Y how much is a 2, right? So that's the reason it has got the +2. Okay, don't get confused. Now you can see from the 0 to +2 it has came, then that's the reason it is oxidation, right? -2 to it has reached to the -3, right? It has reduction. Done. Here -3 to the -2 to -3 it has came, right? Minus, in the minus it has been increased, means that is reduction. In the 0 to +2 it has came, means loss of electron, oxidation, right? Second one, second type we are having intramolecular redox reaction. What is the meaning of the intramolecular redox reaction? Means same substance undergoing oxidation as well as reduction. What? Same substance undergoing both oxidation as well as reduction. Same substance undergoing both oxidation and reduction is nothing but intramolecular redox reaction. That is KClO3 if you take. Now that it will give you the KCl plus O2. Don't think about the balancing, just see. Now you can see here the potassium oxidation number is +1, chlorine oxidation number is +5, oxygen oxidation number is -2. That here the potassium oxidation number is +1, chlorine oxidation number is -1, oxygen oxidation number is 0. Now from the chlorine to this chlorine, it is loss of electron or gain of electron? It is reduction, gain of electron, because +5 to -1 it has came. Now oxygen case you see, -2 to 0 it has came. -2 to 0 it has came means it has been oxidation, right? Means in the same substance, the elements, one it is undergoing oxidation, one it is undergoing the reduction. Clear? This is known as the which one? Intermolecular redox reaction. The next type, same substance undergoing oxidation and reduction. My dear friends, you have to be very careful because you will get some confusion between the which one? Same substance, one element undergoing, same substance undergoing both oxidation, same substance, better you write like this, same substance, one element, same substance, one element undergoing oxidation and one substance reduction. One substance, see, chlorine is reduction, oxygen is oxidation. Next type of the very important that we are going to see, that is a disproportionation reaction. Disproportionation reaction. Next one, the next one we are going to see, very important reaction that we are going to see here in these very repeated questions. They may ask, what is the meaning of the disproportionation reaction? Disproportionation reaction. Disproportionation reaction means the Very important key point that you have to remember. In the disproportionation reaction, same species undergoing or same substance undergoing both reduction and oxidation. Same substance undergoing reduction and oxidation is nothing but what? Disproportionation reaction. Example, if you take the Cl2. In the Cl2, it will undergo Cl minus plus ClO3 minus. Now you can see here it is undergoing from the 0 minus 1. From the 0, it is undergoing plus 5. Done? I hope it is clear. I hope it is clear for everyone. Disproportionation reaction means. Now the another example, one it is undergone. This is reduction. Now this is oxidation. Now next one. Next. Fourth type we are having, that is comproportionation reaction. Comproportionation reaction means it is a reverse of disproportionation reaction. Reverse of disproportionation reaction is nothing but comproportionation. Here let's suppose Cl minus plus ClO3 minus gives rise to Cl2. Reverse only, right? This is disproportionation reaction. Reverse of this reaction is comproportionation reaction. Done? Next. The next one we are having another classification of the redox reactions. Another classification of redox reaction. Now you see, now intramolecular means same substance, one element undergoing oxidation, one element undergoing reduction. In the this is substance same, but one element is undergoing oxidation, one element is undergoing reduction. See, chlorine is undergoing reduction, oxygen is undergoing oxidation. But disproportionation reaction means one substance only, the same substance or the same element undergoing oxidation and reduction. But in the intra means in the one substance different elements will be there, right? That one is undergoing reduction, one it is undergoing oxidation. But here in this case of the disproportionation, one element itself undergoing oxidation and reduction. I hope it is clear. I hope it is clear, or still you are having any confusion? Right? No. Clear, right? Done. Next. Next we are having another types of the classification of the redox reaction. In that first one, combination redox reaction. What is the meaning of the combination redox reaction? Means two or more molecules combine together to form third. Combination means two or more atoms combined to form the third. Or this is one molecule, this is second molecule, combined together to form the one third molecule is known as a combination reaction. Example, carbon plus O2 gives rise to CO2 is nothing but combination reaction. Lithium plus nitrogen N2 gives rise to lithium nitrate. Second one, decomposition reaction. Next one is a decomposition reaction. What is the meaning of the decomposition reaction? Here, when a molecule breaks down into two or more components, at least one should be in its elemental state. In the decomposition state, this is very, very important. When a molecule break down into two or more components, at least one should be in its elemental form. If it is present in its elemental form, then only we can say it as a decomposition reaction. Example, 2KClO3. If you heat it, then it will be converted into the 2KCl plus 3O2. Now you see oxygen is in the elemental form, right? Now if you take the ammonia upon heating, it will be converted into N2 plus 3H2. Done. Third one we are having the displacement reaction. We are having. What is the meaning of the displacement reaction? Atom or ion in a compound replaced by the any atom or molecule. Clear? Now, displacement means high reactive metal will displace low reactive metal, right? High reactive metal will displace low reactive metal. High reactive metal displace low reactive metal. Now, example, CuSO4 in the presence of Zn solid. Clear? Then what it will happen? Cu has been replaced and the ZnSO4 has been formed. Here how? From the +2 oxidation state of the copper, it has been reached to the 0, and the 0 oxidation state of the zinc, it has been reached to the +2. Now this is a displacement reaction. Next, this is metal displacement. In this only we are having the one another type, that is non-metal displacement. One another type we are having, that is non-metal displacement. Non-metal displacement means Zn plus 2HCl gives rise to ZnCl2 plus H2. Clear? Now this is a metal. Now hydrogen is a non-metal. Clear? Next, the next very important we are having, that is oxidizing power of halogens. What we are having? Oxidizing power of halogens. Oxidizing power of halogens. Right? Now, in this oxidizing power of the halogens, now listen carefully, my dear friends, the one who are in the live. Here, when it comes to the oxidizing power of the halogens, here fluorine will readily take the electron or readily will give the electron. Can anyone say me? Fluorine will readily take the electron or fluorine will readily give the electron? Fluorine will readily take the electron or fluorine will readily give the electron? Can anyone? Will readily take the electron, right? Now here fluorine will readily take the electron means it will readily reduce or it will readily oxidize. Can anyone? It will reduce. Clear? Clear? Now it will reduce, right? Here then fluorine, if they have given fluorine being the more electronegative, what it will do, it acts as strong oxidizing agent, right? Now if suppose F2 they have given, F2 when it is reacted with the halogens 2x minus means here the X may be Cl minus, Br minus, I minus, right? Fluorine will never and ever will be oxidized, my dear friends. For when the halogens, when it is reacting with the halogens, it will never and ever it will be oxidized. You have to be very careful with this one. Clear? The fluorine oxidation number here it is a 0. Halogens either it may be the chlorine, bromine, iodine, it is a -1. Then it will reach to the F minus and it will reach to the X2. See, halogens oxidation number from the -1 it has reached to the 0. From the 0 it has reached to the -1. Means from year to year what it will happen? Reduction. Now year to year it has been oxidized. Clear? You have to be very careful with this one. Let's suppose Cl2 they have given. Cl2 you have to be very careful. Cl2 will not oxidize fluorine but can oxidize bromine and iodine, Br minus and the I minus, but it will not oxidize F minus. Clear? You have to be very careful with this one. Now if suppose if they have given 2x minus, that is Br minus comma I minus, it will be converted into 2Cl minus plus X2. Then Br2 if they have given Br2 plus 2I minus gives rise to 2Br minus plus I2. Now these are the reactions that we are having the oxidizing powers of the given compound. If suppose if they ask what is the oxidizing power, what is the oxidizing power of the halogens if they ask? Now you say me, if suppose if they have given the F2, if suppose if they have given the F2 comma Cl2 comma Br2 comma I2, if suppose they are asking the oxidizing power, say me order, you say me 1 2 3 4 order, oxidizing power order, oxidizing power order. Oxidizing power order. What is the oxidizing power order? Yes. 1 greater than, 2 greater than, 3 greater than 4. Good. Oxidizing power order will be 1 greater than, 2 greater than, 3 greater than 4. No. Oxidizing power means itself reduce and oxidize others. Itself reduce and oxidize others is nothing but oxidizing power. See, the fluorine itself oxidizing the which one? Fluorine itself reducing and oxidizing the which one? This one, right? Oh, cha. Okay. Increasing order. Okay, done. Okay, fine. Now, very most important concept now we are going to study, that is a balancing of redox reaction. This balancing of redox reactions will play a very crucial role in the second year when we are going to start the redox reaction. So balancing of redox reaction, first I will explain in elaboratedly. Then after that, very fastly how to balance a redox reaction I will explain. Balancing of redox reaction we are having in the two types. One in acidic medium. One is in the acidic medium. Acidic medium means H plus, and one in the basic medium, that is a OH minus. Okay. First I will explain in the acidic medium. Done. First I will explain in the acidic medium. Based on that, after that I will explain in the basic medium. First elaboratedly I will explain. Then after that, whatever may be the doubts you are having, you can ask, and based on this one, the concept, next thing, the next I will give you the questions within the fraction of seconds. You have to send me the answers. First, in the acidic medium we'll go. In the acidic medium, balancing of acidic medium. Now, the reaction we are having MnO4 minus plus C2O4 minus 2 gives rise to Mn plus 2 plus CO2 they will give you. This is the reaction they will give you, and they will ask you to balance the reaction in the acidic medium. First thing what you have to do, step 1, divide reaction in oxidation and reduction of reactions. Done. First, how to divide the oxidation of reaction and the reduction of reaction? By the oxidation numbers. Now here it is a plus 3, here it is a plus 4. Plus 7 to plus 2 is reduction. Plus 3 to plus 4 is a oxidation. Right? Now this is the first one, oxidation. Now here it is a reduction. Done. Now oxidation, what we are having, C2O4 minus 2 gives rise to CO2. Now here MnO4 minus gives rise to Mn plus 2. Done. This is the first one. Second one, what you have to do, balance atom other than oxygen and hydrogen. Now you see here how many carbons we are having? 2. Product side only 1. So C2O4 minus 2 gives rise to 2 CO2. Done. Here how many Mn we are having? 1. Here also 1. So MnO4 minus gives rise to Mn plus 2. Done. This is step 2. Now step 3. In the step 3, what we have to do, balance oxygen atoms by adding sufficient H2O. Now you can see here this is C2O4 minus 2 gives rise to 2 CO2. C2O4 minus 2 gives rise to 2 CO2. Next one. Here MnO4 minus gives rise to Mn plus 2. MnO4 minus gives rise to Mn plus 2. Okay? Right. Here how many oxygens we are having? 4. Here how many we are having? 4. So balanced. Here how many oxygen we are having? 4. Here how many we are having? 0, right? So what we have to do? We have to add the 4H2O here. Done? Balance. Next. Balance H plus hydrogen or balance hydrogen atoms. Balance hydrogen atom with sufficient H plus. With sufficient H plus. Right? Now, here how many hydrogen atoms are you having? No hydrogen atoms in this case. So, C2O4 minus 2 gives rise to 2CO2. But here how many hydrogen atoms we are having? 8, right? So, add the 8 H plus in this manner at the reactant side. Gives rise to Mn plus 2 plus 4H2O. Right? Now, oxygen balanced, hydrogen balanced. Now, the very important thing, and the many of the students, they will get the mistake and they will do the mistake, balancing of the charge. Now, listen carefully how to balance the charge. I will explain. Balancing of charge. How to balance the charge means, here C2O4 minus 2 gives rise to 2CO2, right? Now, next one. Next reaction we are having MnO4 minus, by taking the 8H plus, gives rise to Mn plus 2 plus 4H2O. This is a reaction up to now we have balanced. Here what we have to do means, here you can see from C2O4 minus 2, from the plus 3 to plus 4 oxidation state it has went. Then what is the change in electrons, they will ask. My dear friends, many of the students, they will make the mistake in the oxalic acid. What the mistake they will do, you know? Here it is the oxidation state plus 3. Here it is a plus 1. They will think that the change in electrons are only 1. But the main mistake you are doing over there only. Here you can see how many carbons are at the reactant side? 2. How many carbons we are having at the product side? 1. So for the 1 carbon, if you are having the change in electrons are 1, means for the 2 carbon, the change in electrons are 2. My dear friends, you have to be very careful with this one. Don't substitute 1. If you substitute the 1 over there, you will get the wrong answer. Done? Now here the Mn, here to here it is a 5. Clear? Now here carbon has lost the how many electrons? Carbon has lost the 2 electrons. Loss of electrons should be at the product side, and manganese MnO4 has gained the 5 electrons. Gain of electrons should be at the reactant side. Clear? Loss of electrons should be at the product side. Gain of electrons should be at the reactant side. Then to balance the charge, we have to multiply with 5. We have to multiply with the 2 for the entire reaction. If you multiply the entire reaction, first one with the 5 and the second one with the 2, then the reaction will become 5C2O4 minus 2. Clear? Gives rise to 2CO2 plus 10 electrons. And the second reaction will become 2MnO4 minus, not 2, 4. Sorry, 2 only. 2MnO4 minus plus 16H plus 10 electrons gives rise to 2Mn plus 2 plus 8H2O plus 8H2O. Now 10 electron cancel. Then next one we have to balance the reaction. 2MnO4 minus plus 5C2O4 minus 2 plus 16H plus gives rise to how much? 2Mn plus 2 plus 10 CO2 10 CO2 plus how much? 8H2. Now both the sides the charge balance or not. Now we have to see. Here it is a minus 2, minus 10. Minus 2, minus 10, it is a minus 12. Minus 12 plus 16, it will give you the plus 4 electrons. Right? Now here is the 2 into 2 plus 4 electrons. My dear friends, if this both the sides, if the electrons are balanced, then only the reaction is balanced. Then only the reaction is balanced. If the both the sides electrons are balanced, then only the reaction is balanced. My dear friends, you have to be very careful with this one. If both the sides electrons are not balanced, then the reaction is not balanced. Good evening, Film Star, Films. Something, may I know your name? Next. This is in the acidic medium. Now we'll go with the basic medium. Now we'll go with the basic medium. Second one in basic medium. In the basic medium, the very important thing you have to remember is MnO4 minus plus I minus gives rise to MnO2 plus I2. Right? Now, here same thing. Again oxidation of reaction, reduction of reaction. Same. First one, balance the atoms, reduction of reaction, and it is a MnO2. Done. Next after that we have to balance the atoms. Here the 1, here we are having, convert better, you balance the 2 here. Instead of balancing it the half, balance it the 2 here. 2, here it will become I2. Here how many Mn? 1 Mn we are having, MnO2. Right? The next thing we have to balance the oxygens, right? How to balance the oxygen? 2I minus gives rise to I2. Next, here the MnO4 minus gives rise to MnO2. Here how many we are having? 4. Here we have to add the 2H2O. Very key point you have to remember in the basic medium. Many of the students, they will forget and they will get the difficulty to balance in the basic medium is, key point is add sufficient H2O molecule where deficiency of hydrogen present. Okay, and simultaneously add same number of OH minus ions in the opposite side. Clear? This point is only for the basic medium. If you remember this key point, then you will never and ever will do the mistake in the, which one? In the basic medium balancing. Clear? Now we have to balance the hydrogen. Here hydrogens are not there. Here only will do. How many hydrogens we are less? 4, right? So 4 H2O we have to add at the reactant side. At the same time, opposite side 4 OH minus we have to add. How? That is 2 I minus gives rise to I2. Done. MnO4 minus plus 4 H2O gives rise to MnO2 plus 2 H2O plus 4 OH minus. Now you see oxygens and nitrogens are balanced or not? Total how many oxygens we are having? 8. Here 4 plus 4, 8. Here 4, here 2, here 2, 4, here 4, 8. Hydrogens 8, here 4, here 4. Total balance. Then after that, we have to balance the electrons, right? Use raised to I2. For the 1 iodine, how many electrons it has lost? 1 electron. So for the 2 iodines, it will lose the 2 electrons. Done? Now, here the MnO4 minus, it has gained the 3 electrons. It has gained the how many electrons? 3 electrons, right? Because here it is a plus 4, here it is a plus 7. So it has gained the 3 electrons to give the MnO2 plus 2H2O plus 4OH minus. So to balance the electrons, we have to multiply with 3. This we have to multiply with 2. Then the entire reaction will become, what it will become? This is 6I minus gives rise to 3I2 plus 6 electrons. Next one, this will become 2MnO4 minus plus 8H2O plus 6 electrons gives rise to 2MnO2 plus 4H2O plus 8OH minus. Now you can see 6 electron cancel. Done. Then if you add the final equation, what you will get? If you add the final equation, then the final equation you will get it as 2MnO4 minus plus 6I minus plus 8H2O gives rise to 2MnO2 plus 3I2 2MnO4 minus plus 3I2 plus 4H2O plus 8OH minus. Now we'll see both the side charge balance or not. Now this is minus 2, minus 6. This is minus 8 electrons. Now here also neutral, 8 into minus 1, 8 electron. Both the side charge balance, then the reaction is balanced. Now in this manner we have to balance the reaction in the basic medium. Okay. Now how to balance the reaction in the acidic medium and how to balance the reaction in the basic medium we have seen. My dear friends, by this I will stop the lecture here. Now tomorrow I will update the lecture time so that tomorrow we can finish what we can finish tomorrow, how to balance the reaction very fastly without doing the n number of steps. Then after that we will see the n factor calculation, equivalence weights, then after that titration, and we'll stop the concept and we'll do the questions. Okay. Now by that I am stopping the chapter here. Tomorrow is a very important that we are going to study, that is equivalent concept n factor. By that n factor, how to calculate the which one, given reaction n factors, equivalent weights, that we are going to see tomorrow. Okay my dear friends, see you tomorrow. I will update you the class timings in the Instagram. You can check over there, or I will update you in your groups. Okay. Question session is tomorrow. Tomorrow morning I will finish the content. Evening I will start the question session. Question session of mole concept as well as the redox reaction. Both. Question session of both I will do tomorrow evening. In the evening I will do. Okay. Tomorrow morning I will come. I will finish this chapter, entire chapter, and the question session I will start it at the evening. Okay. Any doubts? Still you are having any doubts? Anyone are having any doubts? Okay, done. Okay, bye. See you tomorrow. Okay, bye. See you tomorrow.